singularities hub. The quantum chips take microseconds to do the task of supercomputers would spend 9,000 years on. And a new study in the Nature said no. A cleverly designed quantum device developed Xanadu, a company. Xanadu company based on Toronto, Canada. Obliterate conventions computers on a benchmark task would otherwise take over 9,000 years for the quantum chip. Borealis' answer came with 36 microseconds. Xanadu accomplishment is the latest, demonstrated the power of quantum computing over conventions computer. And the similarly simple idea dubbed quantum advantages. Theoretically, the concept makes sense. Unlike conventional computers, which is calculated in the sequence using the binary bit 0 or 1, quantum device tap into the witness of quantum world, where the 0 and 1 can both exist at the same time, with the differing probabilities to data processed in QB. Non-commutable units, so simultaneous perform multiple calculations is unique. Translations: a quantum computer is like a hyper-efficiency multitasker, whereas conventional computers are far more linear when given the same problem. A quantum computer should be able to trudge any supercomputers in any problem and turn speed, efficiency, idea, depth. The quantum supremacy has been the driving force to push a new generations of computers completely aliens to anything previously made. So problem is proving quantum supremacy is extremely difficult as this quantum device increasingly leave the laboratory solve the more real-world problem. Scientists are embracing the intermediate benchmark. Quantum take advantage, which is the idea was quantum computer can beat conventional one. It's just one task. Back in 2019, Google broke the internet showcasing the first example of quantum computer. What the name? Sycamore solving the computer problem in just 200 seconds. 200 seconds with the 54 qubit bits compared to the conventional supercomputers. Estimate is a wow of the 10,000 years. A Chinese team soon follow with a second fascinating showcase of quantum computational advantages with the machine speeding answer would take a supercomputer over 2 billion years. So yet a crucial question remains. Are any of these quantum devices even close to being ready for practical use? A drastic redesign is easy to forget. The computer rely on physics or current system. For example, tap into the electrons or cleverly designed chip perform their functions. The quantum computers are similar, but they rely on alternative partial physics. Initial generations of quantum machines look like a delicate, shimmering chandeliers, while absolutely gorgeous compared to the compact of smartphone chip. They also completely impractical. The hardware, however, require tightly controlled climbing. For example, near absolutely zero temperatures to the reduced interference boosts the computer efficiency. The core concept of quantum computing is the same qubit, processing the data supervisions of the quantum physics quicker and allow them to the encode 0s 1s plus, so 0 plus and 1 plus, both at the same time. The hardware that support the idea vastly differ. So Google the name is Google Sycamore. More example uses superconducting metal loops, setup popular with other tech giants, including IBM, which has introduced the ego of a powerful 127 qubit quantum chip in 2021. So that's about the size of quarter other iterations from the companies such as Honeywell and IonQ took a different approach, tapping into the ions atoms. So with the one or more electrons removed, their main source of quantum computing. Another idea rely on the photons for the partials of light is already being proven useful. The Chinese demonstrations of quantum advantage, for example, uses photonic device, but the idea also being a shunned stepping stone toward quantum computing rather than the practical solutions, largely because of difficulty in engineering and setup. Photonic revolutions. Xanadu team naysayers run the new chip. Borealis is marginally similar to the one in the Chinese study, uses photons rather than superconducting material for computations. Explained Dr. Daniel. Founder Ramirez University in Brazil. Rio de Janeiro in Brazil was not involved in the study. Its earlier quantum technology demonstrated in Chinese studies was tactical chip with Borealis optical elements can be the readily program, making the less of the single-use device, more of actually computer potentially capable of solving the multiple problem. The quantum program available on the cloud for anyone to explore once you sign up. The chip flexibility comes from the ingenious design and the innovative scheme offer impressive control potentials scaling. The team zeroed in on problem called Gaussian-Boson sampling of benchmark evaluation. Quantum computer prowess the test, while extraordinary difficult computations doesn't have a much impact real-world problem. However, like a chess or go for the measures of performance actors, unbiased judge. Example, quantum computer performance is gold standard solved Gaussian's Boson assembly is a scheme designed to demonstrate the advantage quantum device over the classical computer. So explain broad. The setup is like a Garnival funhouse mirror 10 hollow movie. Spatial state in the light. The photons amusedly encode to the squeezed states and turn into the chip. Embedded with the network beam splitters. Each beam splitters act like the semi-refractive mirror, depending on how the light hits, split into the multiple daughters. So some reflecting back, others passing through the end of the contraptions and array of photons. So the difficulty is to calculate how any individual photons will end up give the detector. So as another visualizations pictures a beam machines, a pack studies brought and in cases to play the dropped pack in the packs or the top, and then the pack for and Boson simply replace the pack and the photons with the goal and the detecting. Taking up the challenge, the new study reimagines photonics quantum device with an admirable 216 qubit, and then contradicting classical design. So device calculated photon speed rather than the previous standard direction. So introduce the loops optic fiber optical to delay photons so they can interfere of specific but important quantum computations. This vastly slimmed down device, so usually very difficult to understand. Largest network beam splitter normally need to the photons communications can be reduced just 3 to accommodate all the necessary delay. Photons interact compute task with other components readily programmable in the beam. So the team was as the standard sanity check certified the output data was correct. For now, study show quantum supremacy remain a convention. Computers have half century as algorithm keep involve convention computers. Neuromorphic computing designs they were readily output. So quantum take advantages of not well defined. So however, it might be the end of story, he continued, but the new study is a leap forward. Quantum physics in the race. So Shirley Fong is a neurologist turning to the science. So she completed her